I'll start recording now. Perfect. Stressed? Is everyone starting to feel overwhelmed? Yeah. Yeah, I think I'm going to only stick with the exception of the final project, and it's my intent now. This week, I'm going to be checking in with all the teams to find out how everyone's progressing, so that everything goes relatively seamlessly for the final project. Oh, which brings up another point. I do want to talk about the final project, and I will do that in just a moment. But yeah, we have, I want to say maybe 6 lectures left, 6 or 7 lectures left. I think our last lecture is May 12th, and then we go into finals. I think even maybe the next day after that, May 13th. Right. I believe that's what the academic calendar said. And so I'm not going to, with the time constraints, I kind of still want to lecture. I want to finish my lectures today on, or I want to continue my lecture today on Mongo. It's likely we will continue Mongo today and finish it off on Thursday is my intention. And then I want to spend the rest of my time being able to talk about alternate methods that web clients and web servers can cross-communicate via WebSockets. And then I also want to introduce React, a front-end framework, so that you understand exactly at least what that technology provides to us. And all the meantime, you could be working on getting your full projects complete. So with that said, I might issue some labs. We'll see. But I'm not going to do any more mandatory homeworks, although it was always my intent to have some homeworks dedicated to the server side. So I'm still going to make those documents available to you. And I think what I'm going to do, given our time constraints, is just make those as optional bonus assignments. So if you are so inclined as to do a homework 6, you can. I've made that document available on Moodle, and really homework 6 is this. It's designing your own REST API along with a API documentation webpage. But I can't stress this enough. It's not a mandatory homework. It's just I am piecing together my final vision of what this course will be. So I want you to have a complete notion of what would be included in that. So this is not something that you have to focus on doing, but if you were inclined, you can go ahead and work on that if you're not feeling super stressed right now. Okay, so let's talk about the. So with that said, that is posted on Moodle, but don't be fearful. I don't have a submission link on there yet, and when one goes up, I'll ensure to highlight that is a bonus homework assignment. Okay, is there any questions related to that? I mean, so the next thing is I do want, so it would be easier for me if you're on a team, if you go ahead and send me a team invite. How many people in teams are communicating through Discord? If you're communicating through Discord, it's very easy for me just to get invited into a shared chat between you and your other team members. It doesn't necessarily have to be a server, but they have the ability where you could do a multi-party chat. And so it would benefit me for those of you to start opening up that dialogue so I can check in with everyone and start providing feedback and doing updates. And with that said, recall that the final project is going to be graded on, I want to say 9 different fronts, right? I have it descriptized in 9 segments. The first was announcing your project and who your teams were. The second part was defining your specifications. The third part was defining your front end, or doing essentially the front end document. Then the fourth part was the back end the server side document. Then the fifth part was the database document. And then you have an audit for the front end, you have an audit for the back end, and you have an audit for the server, for the data end. And so then you have this last hanging piece, which is part 9, which is labeled as demo. And so it was always my intent that for the final project, a portion of that project should be very much in line with what happens in the game dev class, where essentially all the teams have the opportunity to demo out their full stack project for 5 or 10 minutes or so for the rest of the class. And so that we can do the same thing I've been doing with all of you personally, this audit process, where we can actually do a public audit so that everyone can kind of get an idea of how like stand-ups work and how you have an ability to start demoing out content you've produced, code you've produced to other people. I think that's an incredibly important skill set. And I think it's also would be nice for just the class at large to see what everyone else was able to accomplish. So it's my intent to be able to have that that final portion of the grade be wrapped up in terms of just being like a live demo and just an explanation of what your project's going to be. Now, I would prefer so I'm trying to coordinate that's because now this is going to be the thing. I want to coordinate that with everybody. So clearly, the easiest time for that to coordinate would just be whenever the final would be, but then it would be contingent on everyone being able to get the final project out in terms for what we qualify as our finals. So does anyone know off the top of the day, off the top of their head, what the finals date is? Look it up really quick. You want to know what is it? Academic calendar. Nope, let's do 2021. And I'll check back over here. Okay, nope, no response. So let's just check over here. Okay, so let's go over here. So let's see, final exams. Yeah, let's hop. Oh, I guess I got to go here and actually click something. Wait, I want the final schedule. Maybe that's not what I want. I want UNO finals schedule. Oh, that's not quite right. Oh, perfect. Okay, so this is our finals. Yes. And so let's see here. So it looks like we are a Tuesday, Thursday class that meets from 2 to 3:15. So I think our last lecture day, if I'm not mistaken, is May 12th, and our technical or May 11th. I think it's May 11th, and I think our finals is scheduled 2 days later, May 13th. So I would prefer to give the longest amount of time as possible. So this is a thing that I want to know from the rest of the class. Yeah, that's a big oof, right? So I want to have a final demo. It would make sense to do that normally during the finals periods, but if you want more time, then it conflict for one of your finals, you can have quote unquote a backup day. And so this is what I'm tempted to do. Notice all the backup days are May 19th. So I guess what I am communicating to you is ensure we can lock down one of these days in the conflict time, which gives us the maximum number of days for everyone to complete their final projects so that we can have a shared demo day for that ninth portion, which will just be like a small 5-minute or so explanation and trial run of what your application does. And so this can happen at any time from 7:30 to 9:30, from 10 to noon, from 12:30 to 2:30, from 3 to 5. We need to select one of these days though. Like obviously everyone the entire class, if we were to do a conflict time, has to be available for one of these times. So I'm saying this in lecture right now to say I'm going to open up a poll in Discord, and I'm going to need all stakeholders, that means students, to help make a decision on which one of these times are going to be the best time we want to hold the final. And if we can't come up with some agreement, then we'll have to just defer back to whatever our assigned final day is. Okay, does that make sense? Okay, perfect. Okay, let's see. Is there anything else that I wanted to mention before I start today's lecture? I talked about the final. I'm going to check in with all the teams, and how I want to do the final exam. I think that's it. And that there's a bonus homework, but it's not mandatory. Perfect. Oh, the other part is I really like the lab that's associated with this lecture part because it will result in a certification. So I think that's really nice. Okay, so last lecture we stopped, let's see. So last lecture we started with our exploration into Mongo. And so that's going to be the next lab you're going to working on if you haven't started working on it already. And so we had already covered out of these 6 chapters, and these slides are actually pulled directly from Mongo University slides. So you could use this as a resource for the certification process. But let's see, we covered what is Mongo last class. We covered how we can import, export, and query data from Mongo. We started on part 3 here, which is creating and manipulating data. And where we last left off, if you watched the previous lecture, we had discussed how we can create data. And in particular, every time we insert something into a collection, that document is given a underscore ID field. And we can either define that for ourselves if we have already a predefined mapping of how we can provide IDs to our objects or documents, or if we do not, Mongo will go ahead and create one for us. And there is a scheme by which Mongo creates those IDs, but I don't really care about defining what that is. I don't think that's, at this level, I don't think it's worth spending class lecture time talking about. So we'll go and finish the second part of this chapter 3, then this part 3. Part 2. And part 3, perfect. So this is where we left off, creating, and we discussed. So in creating, we in particular left off on updates. So how can we update a document that's already in our collections? So let's go here. Okay, here we go. Perfect. Okay, so updating documents. So one thing, and I don't know if I had mentioned this last lecture, is whenever you go ahead and work with databases, the foundational methods that you interface with any kind of actual serialization usually is this concept of CRUD operations. So being able to create entries or create documents or collections, being able to update the contents of your documents, being able to read from your database or your collections, and being able to delete. So C, create, R for read or query, U for update, D for delete. Excellent. Okay, so picking up right where we last left off, MongoDB has a flexible data model, which means that you can have fields that contain documents, right? And so those fields can be more than just values like numbers or strings. They can also be arrays. They can even be other documents or objects. In this instance, when you have a field that has a document in of itself, we call that a subdocument. So in this instance, are any of these an invalid MongoDB document? Well, let's see. I see curly braces. I see valid keys. I have an ID. This has an ID value. Yeah, that seems right. This has a string value. This is an array, open, close. Each of these arrays have subdocuments where it has a key or field value pair. And so let's see. So this is the first subdocument. This is the second subdocument. This is the end. So 2 subdocuments. Yeah, this is valid. This is a valid JSON. Let's look at this. I have field value, field value, field value. That is valid. And here, field value, field, a object or document, subdocument, actually, with fields and values. Yeah, so all of these here in these 3 examples appear to be valid JSON formats. And so, yes, I can actually see that was indeed what I was asking. Okay, so let's talk about updating documents. So MQL, which is Mongo Query Language, allows us to update documents in one of two ways. We can either update just one document, or we can update many documents. And so if we wanted to update many documents, the general syntax of that would be from the database, we would use the collection name. And from the collection name, there is going to be a method update many. And the parameters are going to have two different parameters. Each of these parameters in itself would be essentially an object, a JavaScript object. The first would be the query object, the thing that we're essentially filtering for. And the second would be the update operator. How are we mutating? How are we changing the state of whatever gets returned into our cursor from this query? And so this update operator with update many would apply that update operation onto all the documents that get returned from this query. On the instance of an update one, it would only update the first document that gets returned from this query. So it finds the first thing that matches that query's parameters, and then it updates that single one. So I do want to highlight, we do have methods for update one and update many. That's not dissimilar to the queries that we were doing. Recall that last lecture, we talked about how we can find documents from our Mongo database, and there was a find method and there was a find one method. And so usually by default, you want to update many things, you want to find many things. But we will, as we examine our CRUD operations, to be able to read things or find things, update them, delete them, we will see how they fit nicely into a ability to do it across many documents versus the ability to do it on just one. Okay, so let's talk about these update operator objects. So again, these are going to be passed into the update method or the update many method as an object, where the key is going to be the operation you want to perform. And so in this instance, our operation could be to increment a field inside of the document. It could be set a field inside of the document. It could be to push a value into an array at a field in the document. Like, all these are valid updates. And so in these instances, our operator is defined prefaced with a $sign. So notice the field inside of all these objects should be like $inc, $set, $push. And this is illustrating the action that's to be performed by this update, by the operator. And then the result is going to be a subdocument. So it's going to be an object itself. And this object will be the field we want to affect, and then how we want to affect it. So in this instance, let's look at this first example. We're going to have an increment operation that will affect the population field, and it will increment it by 10. And since this is an object, I can actually have an increment operation occur on multiple fields. So in this instance, and that would be separated by field of value pair, so a comma for each additional action you want this increment to also affect. So if I only want to increment one thing, it would just be an object that would have one field value. But if I want to do more than one, then I would just delimit it with commas. So in this example, I increment the field value by a specified amount. In the second example, I would set the field defined here of population to overwrite whatever was previously there with this new amount. So this allows me to either overwrite a value or even just set a value if it did not exist there before. And again, I can set multiple fields at once if I wanted to, using just a comma delimited object. And then with push, very same concept. It's just this is going to add an element to the array field. Okay, so if you want to see actual examples of this, I could say, for instance, from my database, access my collection's zip codes. Suppose I had a collection zip codes, and inside zip codes, I want to update all the zip codes such that any document where the city was Hudson, I wanted to increment the population by 10. So again, my update many takes in two parameters. The first is the query. Here, the second is the update operator. In the second example, yes, no, push will overwrite. Will overwrite. So push. So you want to think of push as a mechanism that creates an array for you. So if, for instance, you do the push operation, this is a very good question, by the way. You do a push operation and the field does not already exist, it will create a new array with that field name that has that element of what you pushed into it. If that property already exists, so if there is a field with that name and it was not an array, it will override it with an array and the value that you pushed into it. And if it was already an array, then it'll push that new value into that pre-existing array. So I hope that answers your question. But push is effectively the terminology we use to generate arrays or add elements into pre-existing arrays. So it could be destructive. Anything, set could be destructive as well. I mean, by definition, anything that is an update is a destructive action because you're changing or mutating the state of the document. So destructive is a very harsh term, but yeah, it destroys the old state. Was it done with the slide? Oh yeah. So, and effectively, these are just examples, I think, from the more general thing that we saw. So imagine if I had a database and a collection is called zip, I can just update one. Now, in this instance, typically whenever you do the update one, you specify something that has a unique ID. You don't usually do that with, like, you wouldn't do update one with just city here because you're not guaranteed to know what's getting updated. And it seems weird to have multiple documents in a query where you're only going to select one to do a mutation on. So typically you reserve update ones when you're operating on things that have unique identifiers. In this case, our unique identifier is the zip code. So we're going to query for the zip code, and then we will set the population for that document to be 17,630. And then in this third example, we will go ahead and from our current selected database, we will access the grades collection and we will update one thing, one document from the grades. We will query for the student ID that is 250 and that has the class ID of 339. So this is just illustrating that we can build a query that is selecting on multiple parameters here. In this case, we're checking the equality of two different values of two different fields. And then the operator that we will do will be to push into the scores field an object that is of type extra credit and has a score of 100. Okay, so if I were to give a small quiz here, so where the problem was giving a pets collection where each document has the following structure. Okay, so let's see what this document structure is. I have an ID with an object ID. I have a pet with some type of string. I have domestic, which seems to be a Boolean, true or false, yes or no, it's domestic. I have a diet attribute of whatever this pet eats. And I have a climate, which is an array of, or could be an array of the various climates that this pet could survive in. So then the question is, which of the following commands will add new fields to the updated document? So I want to know, when do I add a new field, not when I update a pre-existing field? And I have 4 different options, but I can potentially select any one of these. I should probably update that slide. So here, I'll do that now. Select all that apply. There we go. Okay. So let's see what we have here. I will update many. So I will query based off of a pet that is a cat. And then I'm going to set. So let's see. I'm going to add a new field with this set. Does a climate field already exist? Does. Now I'm not pushing, I'm setting climate to be continental. So this is also, I think, ties into your question. In this instance, I could take something that was previously an array and overwrite it to just be a singular value. So this set will overwrite this pre-existing field to just be continental. Now, in this instance, I am not adding a new field. I am updating a pre-existing field, so it's not going to be that. So let's check this update menu. I'm going to query for a pet that is a cat. I'm going to set a type that is to be dangerous. Well, let me see. ID, pet, domestic, diet, client. No. So this is going to set a new field for me. So this would create a new field. It's also going to set another field called look. So I'm actually setting two things inside of this operator object. And both these are non-existent. So this would be an example of setting new fields. Let's check this one. So I'm going to query for a pet cat. I'm going to push into it. And this is an instance where I'm going to push continents onto climate. So I will look at climate, which is already an array, or if it wasn't an array, it's now going to be an array. And I'm going to push continental into it. But now also look is not actually a field. I'll look in this, it's not inside of this document. So this is an example of where this will create a field of look inside. So I will update the document with a new field, and it would push adorable as one of the attributes, or one of the elements inside that array. So this does actually also update. So these two update. And then let's see this, domestic. So I'm going to set domestic and diet. Well, domestic and diet both exist. So I can update those values, but I am not going to create new fields. And so if we go and look, yeah, that's exactly what's happening. Those are the, or by exactly what's happening, those are the correct answers. Okay, so now that we've got a little bit of flavor of how we can update values inside of our documents, let's look at the last of the kind of basic operations we can do inside of Mongo, and that's going to be to delete things, or to delete documents, or even collections. So we can either delete or drop methods, or remove documents from a collection, or remove a collection. Our syntax can be as follows. So there's three different ways we can do this. We can either, no, that's not quite right. Either delete many. I could delete one, or I can just drop an entire collection. So if I delete many, I pass in just one query, and whatever gets returned from that query result inside that cursor will be removed. Those documents will be removed from this collection here. And so if I delete one, well, again, typically you only want to delete ones when it's based off of a query that's using an identifier, something that's designed to uniquely select one document. But whichever is the first document that returns from this will be removed from the collection. And then you could just do drop, and drop on the collection name itself removes that collection from the database. So these are the two operations to remove documents from a collection. This allows you to actually remove the collection in and of itself. I will also say, though, if you have a collection that only has one document and you remove that one document, or if you have a collection that has multiple documents, but you remove all the collections in the document, it also, if you remove all the documents from a collection, it also removes that collection. So an empty collection is also deleted. Okay, so let's. I want to group these like we had grouped the previous ones, just to illustrate that we do have methods that allow us to operate on just one document, or to be able to operate on many. And usually it's more common to use the ones for many. So let's talk about examples for deleting a document. So if I had a database, suppose I had a database that had an inspections collection, and I want to delete all documents from the database that had the field of tests where it equaled 1. This is exactly how we do this. So that deletes all documents that have a test field equal to 1. Now, suppose I only want to delete one document, the first document, from a database, from my Mongo database, where the test field was equal to 3. Then it looks exactly like this other query, but I am going to be doing just delete 1. And then finally, if I just want to delete the inspections class entirely, I would do db.inspections.drop. Perfect. Okay, so Let's do a quick comprehension about what we talked about here. Suppose you want to get rid of all the collections in suppose you get rid of all the collections in the database. Does removing all these collections in your database also remove the database? And yes, that is yes, that is a thing. Okay. Which of the following commands will delete a collection named villains? So suppose inside my database, I have this collection called villains. Do I drop that collection using the delete keyword? So would it be A, would I drop the collections using the drop keyword, or would I remove that collections using the drop all method? Well, clearly we didn't learn a method called delete, and we didn't learn a method called drop all, so it's going to be drop. And yes, indeed, that is the answer. Okay, so that finishes up on the third part of Mongo. So we talked about basic CRUD operations. We talked about what is Mongo, and we talked about how to import and export and query data out of Mongo. So let's move on to the fourth part. I think this is the biggest chunk of these slides and of the certification test as well. It's going to be the ability to do advanced CRUD operations. And honestly, this part is what makes Mongo such a powerful tool, especially if you're operating in a full stack JavaScript application. I mean, one of the powerful components about Mongo is it allows our data schema to actually match our objects that we're operating on in memory. And so that's hugely beneficial because we don't have to map from our in-memory data model to some kind of serialized model. It can effectively be the same model. And so Mongo then gives us these really powerful tools to be able to mutate the data in our data store as we see fit. And so let's look at some advanced CRUD operations. So inside this section, we're going to look at how we can build query operators that can do comparisons, or use logical operators, or actually call it expressive operators. We'll also look at how we can do additional operators on array values, and then we'll look at some more array operators in conjunction with the ability to do projections. And then we'll also look at arrays and subdocuments operators that deal with that. Excellent. So before we move on with advanced CRUD operations, let's just take a quick examination of this MQL operators that we talked about in our update method. So recall with update operators, examples included like being able to increment, being able to set, being able to unset. So that all allows us to modify data in the database. So our query operators provide additional ways to locate data within the database. These operators we're about to learn. So before we do that, you have to understand that the $ has multiple uses inside of Mongo. We can use the $ to precede an MQL operator, which is what we saw in the update section, but we can also precede aggregation pipeline stages or access actual field values with the $ as well. So we'll probably see the aggregation pipelines in part 5, but in this part, we will see how we can use the $ to also access values from a field inside of our query, which is really powerful for being able to start making decisions on how to pull or find documents from our data store. So another thing I do want to highlight here is that we can use the simple query or update operators along with the more powerful operators that are common to our JavaScript programming languages. So we can start building queries where we can do comparison operators or logical operations or array-based operations. And so let's start by looking at the comparison operators to get a sense of this. So as you might recall, in Java or JavaScript or Python or any other like programming language, a comparison is one where we can say something is greater than or equal to, it's greater than, it's less than, or less than or equal to. So our syntax for being able to do a query operator would look like this. We would have the field name. So this is the field we want to affect. And so this is, again, all of these operators are inside of objects themselves. So I would have the field I want to affect, and then inside that will be a document, be an object where the field value pair is the operator and then the value that we're using that operator on. So let's talk about what this operator can be. That operator, in terms of Mongo syntax, if we want to do equal to, it's going to be $EQ. If we want it to be greater than, it'll be $GT. If we want to do greater than or equal to, it'd be $GTE. If we wanted to do not equal to, it'd be $NE. If we want to do less than, it'd be $LT, and less than or equal would be $LTE. So this is pretty common. I mean, syntaxes. So instead of using symbols, obviously we use letters to represent this, but still something that should be not uncommon to you. So let's take an example of this. Oh, we also we have the equal to there. So it should be noted that equal to is used as a default operator when an operator is not specified. And so this is why when we do things like updates or whatnot, and we just have a value, typically it's the default default behaviors to check for equality. Anyway, let's do some evaluations of some of these comparisons, some actual examples. So suppose I had this current database that had a collections called trips, and I wanted to find all documents where the trip duration was less than or equal to 70 seconds, and the user type for the trip was not a subscriber. Okay, so how would I do that? I'm going to do, this is going to be a find operation because I'm trying to query data from my Mongo database. And so here, I'm going to use the field name, right? Because I want to do one of these comparison operators. So under the field trip duration, I want to check to see when the value is less than or equal to 70. So the operator I want to use is going to be less than or equal. And then this is the actual value it's going to apply this comparison for. And so then I'll get a return on all things, all documents where this is going to be true. And then in addition to that, I can create another parameter here inside of my query to check for when subscriber on user type, when it is not equal to subscribers. So it could be any other thing besides subscribers. So when these two conditions are met, or whatever documents these two conditions are met for, I will then get a result from that. So you can see how this allows us to start building more powerful and comprehensive queries. Okay, let's look at this example too. Inside here, I'm going to find all documents where the trip duration was less than or equal to 70 seconds, and the user type was customer using a redundant equality operator. Yeah, well, that just explains what's happening in here. But inside of the actual query on the current database, we're going to access the trips collection. We're going to do a query, so we're going to find something from it. We're going to pass the query object. Our query object has two different fields. The first, we're going to check the trip duration, and we're going to see when the trip duration is less than or equal to 70. And here we're going to check when the user type is equal to customer. And again, this is redundant because the default behavior is typically to check for equality on find operators or on these query objects. And in this last example, we're just going to go ahead and do what we've kind of learned how to do this before. So this is using the explicit equality operator, the way that you might have recalled us doing this in the previous section where we just do the field and value we're querying for is technically what's called an implicit equality operator. So in this instance, we're doing the same thing as example 2, but you can see the syntax is slightly leaner. And so here we're just banking on the fact that the default behavior is equality when we don't give it a comparison, a comparator operator object. Excellent. Okay, so let's do a little comprehension to see if how much of this makes sense to us. So suppose we have this problem. How would you define a comparison query to find all documents that have fewer than 1,000 people listed in the population fields for the zips collection? Okay, so let's see if this doesn't make sense. So we could, from the database, we have this zips collection, and we want to find inside of the field that is the pop field. So inside the field that's population, we're going to pass in this comparator operator, where the field is, we're checking to see if it's fewer, so it's going to be less than 1,000. And then if I want to get the number that's going to be, I can then just ask it for the count. Okay, suppose we had this other problem. Suppose that we wanted to, how would we define a comparison to query to find the difference between the number of people born in 1998 and the number of people born after 1998 from a collection named trips. So let's see, we might do that this way. We could use the greater than instead of the greater than equal operator to exclude all 1998 births. So here in my database, in my trips collection, I will find the property that is birth year, and then I will search for all those birth years that are greater than 1998, and I will get that count. And then here I can go ahead and find inside of my trips collection the birth year where it is equal to 1998 and get that count. And if I want to find the difference, I could just take one number, subtract it from the other. Okay, let's see here. Suppose we have this problem. From the routes collection, okay, we want to find out which of the following statements will return all routes that have at least one stop in them. Okay, and we have to select all that apply. So which of these queries, so we get it. One of the nice things about queries is we can define them in separate ways. That's true for most ways of implementing code. So in this instance, what query satisfies that requirement? Well, let's look at A. From the current database, I have this routes collection. And so I want to find some documents on there where stops is not equal to 0. Well, let's see. Routes have at least one stop. So if it's not equal to 0, well, that seems like a good way to go ahead and get at least a route that has at least one stop. Okay. So this could be a valid way to do that. So let's look at B. In our database, we have a routes collection, and we want to find on the fields property stops greater than or equal to 0. Well, no, because this is going to return documents that have 0 stops in it. So this one would not be valid. Let's look at C. We have a database that has a routes collection. We want to find from it this field stops less than 0. Nope, that's not going to be what we want to have at least one stop or more. So let's look at D. So a database that has a collections of route, and we're going to find on it stops where it's greater than 0. Oh yeah, that'll work as well. So I would say A and D would be appropriate ways to go ahead and satisfy that demand, or satisfy those requirements. Okay, we've talked about comparisons pretty deeply, I think. Let's move on to logical operators. So suppose we have, so logical queries utilize logical operators. So you can think of those as the and, or not. The way that we can go ahead and represent this in our Mongo query language syntax would be not dissimilar to how we did comparisons, but since these are going to be able to join things together, we'll have an array. And so that makes it a little bit different. So notice inside of my operator object, I'll have the operator type, which is going to be the logical operator I want to apply. And then in my inside of my value, it would be an array, a collection of queries that I want to combine together to get a singular result, right? So let's see how our operators would be defined as. Again, all of our operators are prefaced with a $sign. So I have and, or $and, $or, $nor, and $not. So the and obviously matches all the specified query clauses. The or would mean at least one. So this is not dissimilar to how you already program. The not negates the query requirement. So the one different one you might not be familiar with is the nor, where it would fail to match both given clauses in the binary operator. Okay. And then and is used as the default operator when an operator is not specified, just like the quality operation is the default operation. So let's look at how that might manifest itself based off what we've already seen. So in the instance where we've built complex query objects, and by complex, I mean they have more than one field value pair, we implicitly understood that to be both those things had to be true for that document to get returned. So that was an implicit and operation we were doing. So in this instance, when we did a query object that checked the sector to see if it was a mobile food vendor of 881 and the result was warning, then we knew that these two values had to be in the document to get in all the documents returned from that find. So that was actually the same as building this query operator that used an and operator. And then the value would be this array that has the two different objects that we're trying to utilize on our logic operator. So the first would be the sector, when sector was essentially equal to mobile food vendor, and when result is equal to warning. Now, notice these themselves are query operators, right? That's a big thing that I specify here. These are query operators, which means that I'm implicitly doing the equality operator here, but you can imagine that this could actually be comparison operators that I'm doing here. So you could start to really see the power of being able to do both logic and comparison or comparator operators. And so here, this is an example of that, actually. So imagine here, we wanted to find students whose IDs were greater than 25 and less than 100 from our database sample training in the grades collection. Well, then the query operator I would use a logical operator, so it would use the and keyword. I don't have to, but this would be the most verbose way of doing this, because remember, this is implicit. And so I can then, inside of the array of queries that it will evaluate, the first one will be this query object where the student ID is greater than 25. And then on this one, it'd be where the student ID is less than 100. So this is a perfectly viable way of producing the documents that meet this requirement. But I could alternatively say, oh, this and is default behavior. So I don't necessarily have to define an operator then. I can just nest this inside of this query operation with this query object that is just going to say, okay, give me a student ID where it's greater than, where the student ID, give me a student object where the student ID is greater than 25 and where the student ID is less than 100. I guess this is grades, not students that I'm looking at. And then even then, we can make this even better, because since we're operating on the same field here, recall that this object that has a key value pair can be delimited using commas. So I can actually combine these two into this one much more succinct query object. So given the student ID, I want to do two comparisons. The first comparison is a greater than 25 and a less than 100. So all three of these are the same way of doing the same thing. But you can see the better approach is the most readable one, which would be the third one, because there's much less parsing you have to do. Okay, so so we talked about the explicit and. So when you need to include the same operator more than once in a query, that's typically when you want to do the explicit and. So so suppose, for instance, you wanted to do a query such that you were doing an or between your destination airport and your source airport between these two attributes. And you also wanted to check an or between this airplane CR2 and this airplane A81. So you'd have these two different or operators, but if you could conditionally, or if you have to conditionally factor in both these things, but it could be one or the other of this and one or the other of this, then that might be an example of when you want to use your explicit or. Okay, we already covered this. This is pretty much the same thing. So an example of that, what I just showed previously, I don't know how this slide got in between, would be, so an example of this as it would actually be manifested would be right here. So you can see how these query operators can get kind of large, and so when they start getting larger, it might be easier for you to parse them by making a multi-line like this. So in this instance, imagine we want to find all the documents where the airplane CR2 or A81 left or landed in the KZN airport from the routes collection. And again, if I were to parse this inside my current database, I have a routes collection. It's on my routes collection. I would want to find where both these result into true. So where either the destination airport or the source airport is KZN, and the airplane is either CR2 or A81. Okay, so suppose I wanted to define a logical query that finds how many businesses in the inspections collection, this should say collection, not data set, have the inspection result out of business and belong in the home improvement contractor 100 sector. So how can I define a query that does that? Well, let's take a look. From my database, I have the inspections collection. Inside my inspections collection, I want to find a query such that the result is out of business and sector is home improvement contractor 100. So again, this is an example of just a trick question where we can just use the implicit and. We don't have to use an explicit and. Okay. So let's look at this particular query operator. Suppose we had this problem. What is the most succinct query to return all objects from the inspection collection where the inspection date is either February 20 of 2015 or February 21st of 2015, and the company is not part of the cigarette retail dealer 127. So we want to find the most succinct way of doing this. Well, that's going to instantly knock out number 2 here, because recall that the AND operation is going to be an implicit operation. And since we're not dealing between two things that are essentially ORed, we could ensure that that both these will go ahead and trigger. So we could likely filter out and. We'll read it through them all, but we can likely figure out, cancel out this middle term, because it looks like this middle term and this first term are doing the same thing, but one's using the implicit and, the other's using the explicit and. Then let's see what's happening here. So here, this is using the not, whereas this is using the not equal. And so the not is going to negate out this term. So it's likely going to be this choice A here. And so we see, yes, that's indeed what it is. This query accounts for both dates that are looking, right? We're doing the or between this date, that date, and not equal to this. And so here, we're really looking for a not equal for this. We're not looking for a not, because a not is supposed to produce the opposite of this. So I don't think we'll even get the result we want using the not operation there. Okay. Imagine if we had this problem. Define a logical query that finds how many zips in the zips collection are neither overpopulated or underpopulated. And in this case, we consider population of more than 1 million to be overpopulated and less than 5,000 to be underpopulated. So we want to try to create a query that will meet these criteria. And so here we can say, oh, maybe I should undo that so I don't mutate things too much. Okay. So here, if I want to do that, I could use this would be a good example of using the NOR operator. So here inside my current database, I have the zips collection, and here I want to find when the population is less than 5,000 or the population is greater than 1 million. So these are the two opposite things. So I could do a NOR operation to get the inverse of that. Okay, let's do one more in this category and then we'll move on. So suppose that we want to define a logical query that finds how many companies in the company's data set were either founded in 2004 and either have a social category code or web category code, or founded in the month of October and also either have a social category code or web category code. So let's break this down. We want to find from a company's collection that were either founded in 2004 and have either a social category code or web category code, or they were founded in the month of October and these same two criteria. So we know that we could probably group these two concepts together. So when we go to design this query, this would be a good instance of when we want to use the explicit AND. Because we want to return the documents where the founded year was 2004 or the founded month was October, and the category code was either web or the category code was social. Are these making sense, going through these problems and defining these queries? Is this coming across clear to everyone? Excellent. Okay, so I want to move on to the next type of query then, the expressive operator. And so here, the expressive query operator allows for more than one simple operation with an aggregation syntax. Expressive query operators also allow for us to access field values from documents directly for comparison. So let's see what this actually means for us. So here, we can use the operator expressive, which would be $EXPR. And again, it's going to allow the use of some expression inside of here. So the field name is going to be EXPR. And this is going to allow us to actually use variables and conditional statements. So what does that mean? Well, first, we've learned a new use of the $sign. So up till now, we've only used the $sign to denote a use of an operator, but we can also use the $sign to essentially dereference the value of a field to get its actual value in our query. So let's see what that actually looks like. So imagine this is what I want to do for this query. I have a EXPR for an expressive query where I'm checking for equality, right? The $sign here is a equality operator, it's an operator. And then since I can then pass in an array, right? Where I'm dereferencing the actual value of start station ID, right? So 439, and I'm dereferencing the value of end station ID. So that would be also 439. So in this case, it will actually pull this document because it's actually it's looking at the actual dereference values and checking the equality of those two things. So let's see when it might be different, where it instead of start station ID and end station ID, I could potentially even do like start station name or any other field I can dereference and do comparisons to other fields inside that document. Okay, so let's just take a closer look of how this might look and talk about what we mean by aggregation syntax versus the MQL or the Mongo query language syntax that we've been learning. So inside of here, I have this query object. My query object is going to use that operator EXPR, right? So we haven't talked about aggregation frameworks or aggregation syntax yet, but notice what that really means is in aggregation syntax, I use an operator as my as the field name, and then inside the object would be the field's value pair. Whereas what we've seen previously in the MQL syntax, we were using the field like population, and then inside of the object that was part of this MQL syntax was the operator like greater than or less than, and the value we were comparing it towards. So the important thing to know between aggregation syntax and MQL syntax is it flips the position of this field and operator here versus here. So again, what that means for us is here, this isn't the property name in the document. This is the operator name, expr, right? And then the thing that we're actually passing then can also be a query object. So it can have this this and, which is then going to, as its value, have an array of a collection of things it can evaluate. And then inside of each one of these, it can actually be your check for the greater than or equal to or equality. So here we're checking for greater than, and then we're actually going to, inside of this array, compare the dereference value of trip duration to 1200. And for this equality, we'll check this dereferenced end station ID to the start station ID as well. Okay, so that's the expressive query operator. It allows for more complex queries and for comparing fields within a document. The $ can be used to access the field value. Yeah. And so let's see if we can't look at maybe some simpler examples, since that was purposely designed to be a more complex one. So let's see here, we have, we're using expressive operator, and then the object inside of that, we will search for equality. And then this equality operation is embedded inside of an array. And so for each value here, we will check the equality between the dereference value of end station ID and start station ID. And if we actually want to see this in practice, I could always, I don't know if it's worth actually doing in practice, because I could just copy and paste, but you'll just see the results of the document. So nothing new, just to test it in live code. Okay, and just a quick follow-up on this, like what are some of the uses of the $? Can we use the $ to change the data type into a monetary denomination? No, that's not what $ is used for in Mongo. Can we use $ to denote an operator? Yep, we use it for that. And do we use the $ to signify that you're looking at the value of that field rather than field name? Yep, those are the two use cases we've learned how to use $ for. Okay, so which of the following statements will find all the companies that have more employees than the year in which they were founded? Well, let's look at each one of these. And we would want to select all that apply here. And so in this instance, inside of the current database, I have this collection companies, and I want to find from it, let's see, all the companies that have more than employees in the year in which they were founded. Okay, so here, let's see, I'm going to do this expressive operator. And so I'm going to pass in this query object that's going to do a greater than. And so then this is the operator followed by the set of values. I want to do the operation between. So this is an array. And so inside the array, I'm going to dereference the number of employees and founded year. So number of employees is greater than the value of the founded year. And so in this instance, yes, that's true. That's what we want. We want to find all the employees where the a number of employees is greater than the founded year. Okay, let's see this other one. Here I want to, from my company's collection, I want to find number of employees that's greater than the founded year. Well, this isn't what we're looking for. That's not the syntax we can use for the $ of founded year. And even then, how are we even comparing this? This does not work. This is not how we can do a comparison between two different fields. It's not the syntax that's used. Let's look at this, because we have to use this expressive syntax to be able to dereference things. And so we're not using that, and it's not used by default. So B is a no-go for us. Let's look at this one. So from our database, we have this company's collection, and we want to find from it, yeah, we're doing this expressive query. So on this expressive query, we're going to check is greater than, so founded year is greater than number of employees. Well, this is the right syntax, but this is looking for the wrong thing. This is the opposite of what we're looking for, right? We want a number of employees. So order matters when you're doing greater than, right? So this is greater than that is going to be true. So that's the opposite. And then let's see this. This is appropriate syntax. This is a less than operation. So this is going to return all documents where founded year is less than number of employees. Well, this will do the same thing as A. So both A and D are going to be correct in this situation. Excellent. Okay, let's see here. We have another problem. Write an expressive query that finds how many companies in the companies collection have the same permalink as their Twitter name. So here, if I wanted to do this, I might do it this way. From my current database and my companies collection, I want to find, using Expressive Operator, query operator, where given this object, I'm checking for equality, and inside the array of my equality check, I'm going to dereference the permalink and the Twitter username. Excellent. Okay, so now let's move on. So we've talked about logical operators. We've talked about comparison operators. We've even investigated some expressive operators that start to give us the abilities to start evaluating the actual state of the values themselves, and not just by the keys, by the field names. So let's talk about these operators that we can do in conjunction with arrays. So far, most of the queries we've looked at have really just been on string, number, and Boolean values. But as you might be aware, arrays are complex elements, but they're super valuable. So far, the only one we've seen that operates on arrays is the update. And for that, it was the push operator, which adds a value into an array or creates an array if it wasn't an array already. So let's look at some more array operators in addition to the push, which we've already looked at. We also have the ability to, for these query operators, be able to make decisions based off of size, where it returns a cursor with all documents where the specified array field is exactly that given length. Or we could do all. That's another operator we can do, which returns a cursor with all documents in which the specified array field contains all the given elements, regardless of their order within the array. So you can query an array field, use, let's see here. So let's take a look at an example of this. So here we have inside of our current database a collection that's called listings and reviews. And here we might want to find from it, in this instance, amenities, all the amenities where the size of the array is exactly 20. And the amenities includes all these elements. So we'll only return those documents where the amenities includes internet, Wi-Fi, kitchen, heating, all these elements. So this is an example of how we can build queries that utilize these two new array-based features. Okay. So suppose we want to write an array query that finds the listings in the listings and review data set that accommodates more than 6 people and has exactly 50 reviews. Well, I think, oh, well, this is the answer. I didn't have a before and after. So in this instance, the reviews here, if I want to check to make sure that the reviews are exactly 60, I can go ahead and say on the property of the field of reviews, I want to check the operator of size to be 50. So notice this is just like the comparison operator, right? And here for accommodates, I want to make sure that that is going to be greater than 6 or more people. Okay. And on here, suppose I needed to find this. Use the listing and reviews collection to find how many documents have the property type of house and include changing table as one of the amenities. Well, if I want to go ahead and do a query on that on my current database inside the collections, listing and reviews, I want to find my query object will include the property type house. So notice, and the amenities of changing table. So notice if I only want to find one thing out of many from an array, I can just cite that one thing. I do not have to use all on that. I can cite the one thing I'm looking for. But if it's more than one thing, then I might have to do an element match on it. Okay, let's see here. Which of the following queries will return all listings that have free parking on premises, air conditioning, and Wi-Fi as part of the amenities, and have at least 2 bedrooms in the listing and reviews collection? Well, let's parse through this. So let's see here. Which of the following queries will return all listings that have free parking on premises, air conditioning, and Wi-Fi as part of the amenities, and have at least 2 bedrooms? So inside my database, I have my listing and reviews collection. I want to find from it, okay, I have my amenities, and I want to find free parking on premises, Wi-Fi, and air conditioning. And then I want to go ahead and have bedrooms that's greater than or equal to 2. Well, the problem is this isn't the syntax we want to use to try to hit all those criteria, right? So we learned about the $all, so we want to use that if we were looking for more than one criteria. So let's look at the second option. From the current database, I have a listing and reviews collection I want to find. And here, the idea of what it's trying to do is it's trying to search for each of those amenities one at a time. And then it's trying to search for bedrooms greater than or equal to 2. Do you think that this is valid? Is this valid JSON? What's one of the requirements of JSON for fields? Fields have to be unique, right? And so you can't have 3 fields that are exactly the same. This isn't even valid JSON. Now, this isn't going to populate an error, but what's going to happen is it'll only use the fields of the last one. So that's not going to work. Let's see here. This one is right with the all, but it's wrong with the bedrooms. So the last one's probably going to be the right one. So here, the amenities is going to use the all operator, and then it's going to ensure that all these are inside of that collection. So free parking on premises, Wi-Fi, and air conditioning. And then for bedrooms, it's going to ensure it's greater than or equal to 2. So the option is going to be D in this instance. Excellent. So now let's continue to talk about array operators, but let's throw in one additional thing into this mix. Let's talk about this concept of a projection object. So far, when we use the Mongo query language find method to be able to get information, to get a cursor of documents from our database, we have a second parameter we haven't talked about yet, which is called the projection object. And so a projection object just defines which document fields will either be part of or not part of the resulting cursor. So to give you the basic syntax of this, we have a database. We use a collection name. Then on that, we can find something from it. And what we've seen so far is we can pass into the find method the query object. But in addition to the query object, we could actually pass in the second parameter, which is the project object, which is from that document, what are the fields we want to include that we care about? So you can clearly see sometimes you might have these documents that have so many fields and you only care about 1 or 2 or a few of them. So that's the instance where we use project object, where we can actually just go ahead and isolate the attributes, those fields that we care about in the resulting cursor. So let's take a quick gander at the syntax of the projection object itself. When we go to define a projection object, all it is a object that defines that has the field name of the fields we want and then the number 1 next to it. So we use 1 to include the field, or we can use zeros to filter out a field, to exclude a field. But this is the trick. You can only have your projection object with all 1s or all 0s. So if you decide to include the fields, then it's just got to be the fields you want to include. If you decide to project based off of excluding fields using the 0, then it's got to be just based off of, it has to be all fields that you're excluding. The only time you can mix and match 1s and 0s is if the thing that you're labeling as 0 is your underscore ID. By default, the underscore ID is always part of the projection. So if you're defining a collection of things to include, but you don't want the ID to be part of it, the underscore ID, then that's the only instance where you can include a 0, where the rest of your projection is 1s, right? But yeah, you cannot mix and match otherwise. So just a quick example. Suppose that we were doing this this query where we're searching for the amenities with the size of exactly 20, and where the amenities included internet, Wi-Fi, kitchen, and heating. Then as a second parameter to this find, I can create this projection object where I want to return back inside the cursor document the price and address, and everything else will be excluded. So that will only include the price and address fields in the cursor. So this is a way of just being able to filter your objects down to what you care about. And then the one last thing to be able to, or maybe I'll just pick up here for next lecture. So starting next lecture, we will talk about this new operator for our for arrays, which is called match, that allows us to match a document that contains an array field with at least one element that matches the specified query criteria. So this is just like the domain of this would be just like, or the syntax of this would be just like the all that we used, but the behavior is slightly different. At least one element matches, then it will return that document. And so we'll just pick up as, yeah, I have a little bit more slides in here. So I'll leave off on slide 148. So I should be able to finish out chapter 4 and chapter 5 of this of next lecture, and we'll be done with Mongo by the end of this week, which means that everyone should be prepped up for being able to do their database stuff at this point. So is there any questions before I end today's lecture? And again, we'll finish Mongo out next week. So Mongo will be a rare lecture where it'll cover a week and a half worth of content. There's a lot to kind of go over to get a good comprehension for what you can do with Mongo. But up till now, does this all make sense? Excellent. And you'll get an opportunity to really evaluate this on your own when you work on this lab. So I would implore you to, as soon as you're done with lab 12, start working on lab 13, which is essentially just a certification test, and use this PowerPoint slide as a reference point. And when you're done with that, you'll actually get a certificate. And I'll show that off, I guess, at the very end of this slideshow, so you can see what that would look like. Okay, well, I will see everybody Thursday. And in between then, I will be checking in with the teams. You can help me do that by starting to message me as part of your group, so we can try to set a time that would be good to meet throughout this week. But everyone stay safe, and I'll see you on Thursday. Oh, yeah, I agree. Yeah, you definitely want to include that. That's why I want everyone to get a certificate, so you include it on your LinkedIn account and on your portfolio page and on your resume, in fact. Yeah, I want to try to schedule check-ins with all the teams just to make sure everyone's on track to be successful. And I'm also going to post on Discord a survey of when we could try to do the final demo day.